Hey guys, all right. Now this is a recording for 10.7, okay? I'm going to do some things on the video, but I do need to still go over a lot of things in class. So right now, in your own words, tell me your own definition of a function. Okay, in your own words, tell me what a function is. If you remember from Algebra 1, go ahead and tell me what the definition of function is. Write that out. Now, I'm going to save this whole thing right here, okay? This whole thing right here for class, because I do need to tell you how to use your calculator in class. I need to demonstrate that when you're around. So what we're going to do right now is just to go straight to the parametric equation definition. Okay, so what I want you to do right now is, in your own words, tell me what a function is, and then we're going to skip all the way down to the definition of parametric equations. Parametric equations. So parametric is another way to represent graphs. Okay, just one more way to represent graphs. Okay, here we go. Suppose that x and y are both, oops, I meant to spell both given as a function of a third variable. Let's call it t, okay? And t is the parameter. T is the parameter. Hence, this is called parametric. So the two equations are x equals, okay, something in terms of t, and y equals something in terms of t. Okay, so t is the input for both x equals and y equals. Remember, these are now two equations. Okay, and then both equations, x and y equals, both have an input called t. T is the parameter. So x equals f of t and y equals f of t are called parametric equations. And I need both. So if I said write it in terms of as a parametric equation, then I need both x equals and y equals. Okay, so both of them together are called parametric equations. Each unit of t determines. So each unit of t determines the output of x comma y. Each unit of t determines x comma y. Okay, which, as you can see, well, x equals to f of t, and then y equals g of t. So these are equivalency. So that's all a parametric is. So if I said write whatever it is as parametric equations, then you need to have both x equals and y equals. Okay. Okay. Now, in short, a parameter. Okay, we talk about t being the parameter. A parameter is a special kind of variable where it is a link between x and y variables. Okay, so that's what a parameter is. So it's a link, is to connect x and y. In Algebra 2 Trig, and even in first semester Precalc, we saw a lot of projectile motion problems. So usually I'm going to give you, now you guys have to come up with your own equation. I will no longer give it to you. Projectile motion are normally objects. So projectile motion are normally objects propel upward at an inclination angle called theta. Sorry, there's an A in there. Inclination, that's not a D, but a C. Inclination angle called theta to the horizontal. I write too fast and my pen just doesn't catch up to the Surface Pro. With an initial speed, okay? And this speed, it's called v subscript 0, and that's your initial velocity. And from a height, let's call it h, above the horizontal. Okay, so from now on, you will no longer be given equation to find, before you will give an equation to find, oh, where was the max height? When will we hit the ground? When will, at what time is the max height at? And so on and so on. Now you have to come up with your own equation. So here are the equations to find projectile motion questions. X equals the initial speed, which is the initial velocity, times cosine of theta times t, and t is your time. Then y equals -1/2 g is gravity times t squared plus v subscript 0, that's your initial velocity, times sine of theta, all of that times t, okay? Where t is time, g is constant acceleration due to gravity, and we are usually using 32 feet per second square, or if you see it in meters, then it's 9.8. Whoa, what happened? 9.8 meters per second square. So if the problem's in feet, most of the math questions are in feet. If you're in physics, you're more likely to use meters. Okay. All right. We're just going to do example 1 to see where you're at, and then we'll stop. We will stop the video here. Okay. Here we go. Graph the curve whose parametric equations are given. Show its orientation, super important. Find the rectangular equation of each curve, and then verify using your calculator. This piece right here, we are going to do it in class right now. We're going to do everything without the calculator. Okay. So when it says graph, you're going to start making a table, and this is what it's telling you to do. X is going to be t minus 2. Y is 2 times t plus 3, and t is restricted only from 0 to 2 seconds, and which is pretty cool, right? So if t is restricted from, let me spell everything out that I'm doing. Make a table. Now if t is only from 0 to 2 seconds, that's not too bad. So here we go. Well, at the beginning of t, okay, what's x at? So that's where we're going to plug in x. X equals t minus 2. And then we're going to find y as well. Y is 2 times t plus 3. So when we first start out, which is t equals 0, 0 minus 2 is going to be -2. Then when t is 0, 2 times 0 plus 3 is 3. So what we are going to try to do is graph it right here. We are still going to have x and y, but now x and y has a third variable, time. Okay, time is now on our side. Okay, here we go. 1, 2, 3, 1, 2, 3, 4. So -2, I need to go up 3. Ooh, let's make the y smaller. My bad. because, oh, that doesn't look very good. Okay, let me make y tick marks a little bit smaller. 1, 2, 3, 4, 5, 6, 7. Okay, so -2 go up 3. There you go. This is where it starts. It starts here. Starts. Okay. Now it says show orientation. So what that means is as time goes on, so 1 second, I have to end at 2 seconds. Okay. So 2 seconds, the last stop. Well, 1 minus 2 is going to be -1, and y is going to be, when I plug in 1 for t, 2 times 1 plus 3 is going to be 5. So -1, y is 5. 2, 4, 5. Here we go. So it went from there to there. So it said, hey, show the orientation. So you're going to need to use the arrow to tell me that you're going to go to the right. Then the last one, we are going to stop at 2 seconds. So at 2 seconds, x is going to be 0, and y is going to be, oh, why does it move? Y is going to be 7. So at 2 seconds, remember, you're not plotting time. You're using time to find x, and you're using time to find y. So we only are plotting x and y. So 0, 1, 2, 3, 1, whoa, oh my gosh, this is just driving me nuts. 1, 2, 3, 4, 5, 6, 7, there you go. This is where we are stopping. So it's traveling in that direction. So make a couple of arrows, okay, and that's what happens. It starts where I have the blue dot, and it ends at 0, 7. Now time, we are not plotting time. We are using time to make a table for x, y. Okay, so in class, I will show you how to use a calculator to check. But the next part is says find the rectangular equation of this curve. As you can tell, this curve is a line, okay? So how do we find a rectangular? A rectangular means I need x and y. So the first thing we want to write is if x is t minus 2, that's what it gives you, right? If x equals t minus 2. Then what I want to do is I want to solve for t. Solve for t because I need to plug into my y equals. Remember, it's rectangular, so normally you want y equal to something. So if I solve for t, t equals x plus 2. Now plug this into y equals. Plug t into y, okay? So your y is 2 times t plus 3, so y equals 2. We just solve for t from x. So now it gets x plus 2 plus 3, and simplify that out. So y equals 2x plus 4 plus 3. So y equal to 2x plus 7. Beautiful. This is the rectangular equation. And look at it. It is a line, and the y-intercept is 0, 7. So we are good, and we do have a slope at 2/1. So it is a line. In class, I will definitely show you how to use a calculator. Example B, we are going to do the same way. This time, as you can see, t is restricted starting from 0, but there's no n of that. So we are still going to make a table. T, x, and y. Okay. Since t is starting at 0, I will start at 0. Are you ready? When x is 0, 0 to the half plus 1, it's 1. When x is 0, square root of 0 is 0. Oops. Okay. Next, I'm going to use 1. So, x is, okay, what happened when time is 1? At 1 second or 1 minute, whatever the unit of time is, okay, x is 2. Y, square root of 1 is still 1. Then because y is the square root, I'm going to use nice number. Like 4, like 9, like 16, okay? And normally 4 or 5 dots are plenty. So when x, what is x one time is 4. Remember, this is the same thing as square root of time plus 1. So square root of 4 is 2, 2 plus 1 is 3, and y is going to be 2, okay? And then 1 time is 9, square root of 9 is 3, 3 plus 1 is 4, square root of 9 is 3. When x is when time is 16 seconds or 16 minutes, whatever the unit of time is, square root of 16 is 4, 4 plus 1 is 5, and then y is going to arrive at 4. And then we can go on, but we don't need to. Looks like all of my values are positive, so I don't need a lot of my negative coordinates. I'm just going to use quadrant 1. And let's do it. Are you guys ready? Remember, we're not plotting time. We are plotting x comma y. So it looks like I just need 5 units on the x. 1, 2, 3, 4, 5. Just 4 units up. 1, 2, 3, 4. 1, comma 0. This is my starting point. I'm going to use a different color. 1, comma 0 is right there. That's where I start. Okay? And then I'm just going to, looks like it's getting bigger. So 2, comma 1. Okay. And then 3, comma 2. 1, 2, 3. Right there. 4, comma 3. 1, 2, 3, 4. Right there. 5, comma 4. Okay, so, and remember, we don't stop here because the time is not restricted. We just kind of stop right here because we don't want to go any further. And we need the arrow for directional. And so if you're not listening right now and you don't have your arrow, you will get it wrong on your test, okay? Then we are going to use it to change to rectangular equation. So rectangular equation, remember we want it to be y equals, okay? So first, you're given x equals t to the 1/2 power plus 1, which is the same thing as x equals square root of t, if that's how you want to think of it. Next, we are going to solve for t. So if I were to solve for t, I will move the 1 over, so x minus 1 equals to square root of t. Okay. Then I will attempt to solve both sides by squaring both sides. So t is quantity of x minus 1. I'm going to leave that for now. I don't need to simplify that out. So now I will use y equals square root of t. Well, y equals square root of t, and t is the x minus 1. So I'm just going to plug that in. Square root x minus 1 squared. The radical and power of 2 will cancel each other out. So y is going to equal to x minus 1. Now, as you can see, our y value cannot be lower than 0, right? Because when we plug this in, can you see this right here? The smallest y value is 0. So make sure we limit this right here. So if that's the case, I make sure that x has to be the smallest y value. This is my rectangular, okay? But the smallest y value has to be 0. So the smallest x value it can be is 1, like that, okay? So your domain, I should say, should be exactly what it is originally, okay? All right, next one. And also, this is another line. Okay, so this one is now back to trig. I hope you guys remember trig. Okay, so example C. You know, do me a favor. Let's change this, okay? Just to do me a favor and change this out. Change that out. Okay. X equals 2 times cosine of t, and y equals sine of t. And let's restrict the time in between 0 and pi over 2, which is the first quadrant. So we're just going to make a table. So make a table for time. Time starts at 0. We're going to use all the angles we know. So it's pi over 6, pi over 4, pi over 3, and we end at pi over 2. Then we are going to solve for x. X is 2 to cosine of time. Similarly, we're going to solve for y. Y is going to be sine times time. So let's do the y first. So y is super easy, okay? Sine is 0 is 0. Sine of pi over 6 is 1/2. Sine of pi over 4 is root 2 over 2. Sine of pi over 3 is root 3 over 2. And sine of pi over 2 straight up at 1. Then we can do cosine. Cosine of 0 is 1, but times 2 is 2. Cosine of pi over 6 is rad 3 over 2 times 2, so that's going to give me rad 3. Cosine of pi over 4 is going to be rad 2 over 2, but times 2 in the front, so it's just rad 2. And then cosine of pi over 3 is 1/2, so it gives me a 1. And cosine of pi over 2 is 0. And we are going to approximate the radical 3. Radical 3 is about 1.7. Radical 2 is about 1.4. And because we already know that time is in first quadrant, so I just need first quadrant. Okay. Your x value only goes up to 2. So 1 and 2. Your y value, well, rad 2 divided by 2, this is about 0.7. And rad 3 divided by 2 is about 0.9. So I just really need like 1 tick mark. Okay, so 1 and 2. All right, here we go. At 2, I'm going to stay at 0. Okay, this is my starting location. So that's why the arrow is super important to show directional. At rad 3, which is 1.7, I need to go up exactly a half right there. Okay, so and then at rad 2, which is 1.4, I need to go up a little bit higher than a half. Then 1, I need to go up 0.9, woo, right there, closer to 1, but not quite. And then 0 is straight up at 1. So this is not a line, as you can see. Okay, and it goes like that. And no, I don't put the arrow on the end because it doesn't go on forever. I just need the arrow in the middle. Usually 2 arrows is fine, okay? Around 2 or 3 is perfect. I tend to do a lot more. Now, let's do rectangular equation. This is where it's going to kick you in the butt if you don't remember trig. Because we are in trig, we are going to need to recall some basic trig facts, okay? Okay, so we are going to need to remember sine square of any angle, in this case is sine square of t, plus cosine square of t equals to 1. Okay. Well, since x was given to you, I fix it to 2 cosine of t. I'm just going to solve for cosine of t. Okay, solve for cosine of t. Well, that means I'm just going to divide both sides by 2. So cosine of 2 is x divided by 2. Got it? Okay. Now that I have cosine of t, sine of t is just simply what? It's y. I have cosine of t. I'm just going to plug it in here. Because remember, rectangular is just simply rewriting it all so everything can be x and y. So sine of t is now just y squared. Plus cosine square of t is now x plus 2 squared. Because cosine is x divided by 2. Equals to 1. And let's simplify this out. X squared plus, y squared plus x squared all over 4 equals to 1. So this is an ellipse. Yay! Okay, this is totally an ellipse. And that's exactly how you guys convert your parametric equations into rectangular. And this is the end.